Hi everyone, my name is Ploy. I'm a member of Infra Data Science team at Facebook. Today I'm presenting our work on Seed, which is a statistical analysis tool that allows engineers to test their deployment and run integration testing. This work was done in collaboration with many people in the video infra team. So before we go into details of what Seed is, I want to introduce the background context of how release was done in infra before Seed existed. So in the infra world, we have a concept of shadowing framework. The shadowing framework is the item in the orange block here. So when engineers think about releasing any system change, they would set up a shadowing infrastructure where one tier would contain a production set of the current production setting, and the other tier would contain a code with the new package, with the new change that they want to release, and then they would shadow the two identical sets of production traffic through both shadow tiers. And then after finish running the experiment, they would collect the metrics from running each of these tiers and then look at the metrics and compare the difference between those metrics. Some example of infra experiment would include the change on the system, such as in video infra we would change like encoding algorithm, and these new encoding algorithm between the current one and the new one, we can apply it on the same video ID. So that's why we're able to shadow the identical set of production traffic. This is slightly different from the normal A/B testing setup for the product side, where if you want to put one user in control, you cannot put them in test. It has to be either one of them, right? So previously in video infra, when engineers want to launch any new change, they use the shadowing framework and then they would compare the metrics between these two setup. But then usually the metric collection and measurement was done manually and is not really based on any statistical analysis. In order to make sure that there's no really regression, and they want to, sometimes when they want to make use of some A/B testing capability on the analysis and visualization side, engineers would have to open a user-side experiment to ensure that there's no impact on the user, and also to have the visualization, the static analysis here, even though the actual test that we want to change doesn't really involve any user at all. So you can see that there's a problem and some unnecessary dependency with that existing setting, even though it's worked for many releases in the past. But if you think about it, right, with at least within Facebook, we don't really have existing API that's tailored for infra-side experiment. Most API is tailored for user A/B testing, where the experiment usually runs for a longer time, like 1 week or even weeks or even months. So usually metric aggregation and anything is happening in batch, not a real-time fashion, and engineers would have to wait for a long time to even get the result back for a short experiment. Infra-side experiment, as I mentioned, that one unit of infra experiment can go through both control and test, unlike the user side. So actually infra-side experiment benefit from deterministic allocation rather than the randomization. So if we're forcing our experiment to go through randomization, it really requires a lot more sample, and it's not really a necessity. And because of this, we also spend a lot of time setting up user experiment. It's time consuming. If something goes wrong, we have to repeat the same process again, which slows down a lot of the iteration speed. The fourth point is that when we have a lot of components in the experiment setup, if we see any regression, it's really hard to drill down and debug what is actually the root cause of our metric movement. Is it coming from the user side, or is it really come from the change that we make on the system side? So this is why Seed project was created. We wanted to have a way to quantify impact on infra releases directly on infra metrics before we even think about measuring user impact. So we want to be able to replicate any functionalities that we have on the user side on the infra-side framework. So basically, we can think of Seed as a A/B testing framework for infra releases that doesn't involve any user. And what we did is that we developed three components of Seed. First is the data modeling and pipeline. The second is the API for A/B testing calculation, hypothesis testing calculation. And the third is the visualization, any other things, any functionalities that engineers might want to use on top of doing the metric movement comparison. So yeah, after having Seed, we integrated into the existing shadowing architecture, the orange block from the previous slides. So from production, engineer can then shadow the traffic to production and new package. Right after that, we have a data model and also data pipelining that collect data in real time, do the roll up. Seeds is a program running statistical analysis on these metrics that we are querying. If we see any regression, we send the notification to the engineers who is the owner of the experiment in real time. Any users can also query the result and look at the visualization. They can also export the result to Jupyter Notebook, which also allow them to do some more group by or debugging on the result in order to understand the result of the experiment better. On the stat side of things, we use so far we have implemented the basic hypothesis testing modules like doing power analysis to determine the optimal sample size and minimum detectable effect. On the actual like hypothesis testing, we use two sample proportion tests to find the difference between the ratio metrics such as success rate or error rates. For the continuous metrics, we want to measure percentage change by using delta method. I didn't put any details of the each of these methods here, but happy to answer any questions about it in the end of the talk, or we also have more details on the stat part on the actual paper. For the current deployment status, Seed is currently being used for infra-side experiment analysis, media validation, and package release health check. So mostly three main use case. The first one you see here is the release conveyor. So once the new code is going out, we have multiple like tests and staging, and Seed is one of them. If it doesn't like past this stage, yeah, Seed will block send notification to the engineers and revert the package. And similarly here, this is the alerting that's a result from sometimes that the package have any bad problem, the release is not reliable, etc. And yeah, the third use case is when people actually want to analyze the result, we can also do it here too. So like in this use case, this is the when Seed is run as a library, headless, no visualization, and this is the like visualization and drill down analysis. And because of this, I think we have decreased the deployment time of new package from multiple days with shadow testing and user side experiment to just conveyor release from like multiple days to just a few hours. And we also have the visualization, so the result is easier to understand. People are able to do drill down analysis, even though our drill down analysis is pretty manual at the moment, but we are working on make it integrating some machine learning algorithm to make it more automated. So yeah, as for our future steps, right now Seed is only used within video infra, so we want to have a wider adoption across Facebook infrastructure because we realize that many infra team also undergoing the same process of release. We also want to implement other statistical tests that can leverage the pair nature of shadow experiment. And yeah, as I mentioned earlier, we want to implement some other auto detection of root cause analysis functionality, something that's smarter than just doing like group bys or like regular data analysis. We want to be able to do like anomaly detection or some other approach as well. Yeah, so that's all I have. any questions, anything, yeah, feel free to ask. Thank you so much for your attention.